My name's Alex Theedom. I'm a Java developer. I've been developing Java for about 10 years. I've used Spring, I've used Java Enterprise Edition, and worked in various different domains such as e-learning, cash machines, developed a cash machine for a large Spanish bank, and currently working on a microservice-based lottery system. I've only got 15 minutes to talk very, very quickly about how Java Enterprise Edition, the latest version of Java Enterprise Edition, has changed the way we implement design patterns. So I'm going to look very, very quickly at two of the most commonly known and used design patterns, Singleton Pattern and the factory pattern. And then hopefully, if there's a little bit of time at the end, I'll have a quick review of Facade, Decorator, Observer, and there's many, many more. Okay, so what is it all about? Java EE has changed, the simplified model of Java EE has changed the way we implement design patterns. It has made it much easier to implement classical design patterns, such as the Singleton pattern, for example. And most of these patterns are implemented using annotations. Annotations have replaced, to a large degree, the amount of boilerplate code that we use. And in addition, they have given us additional annotations and an additional control over the way we can implement those patterns. Often quite subtle changes, quite subtle differences, but nevertheless, our implementations have enhanced slightly. In addition, it's given us greater creativity. So let's have a look at the Singleton pattern. This is a pattern that is used everywhere throughout our applications, commonly used by frameworks such as Spring, but also anywhere you want to create an object once, you want it to live for the life of your application, and you're probably not going to destroy it. This is where you want to use a Singleton pattern. So this is what a conventional implementation of the Singleton pattern would be if we were implementing a logger. So this is a thread-safe, lazily initialized Singleton object. Calling the getInstance method on the class name will create the instance. All subsequent instantiations of that method or invocations of that method will return the previously created object. So we use it like this. We call getInstance on the logger, which returns our instance. This is what we do in Java EE. Okay? We have, with this single annotation, we have reduced substantially the amount of code necessary to create our singleton. Here, we are creating exactly the same singleton as we created here, but with substantially less code. This is a lazily instantiated, thread-safe singleton object. And as you can see, the first thing is quite obvious. All we really are concerned about here is just the creational code. We are just interested in creating the code, and we let the container instantiate our object and manage it. Okay? To use it, we inject it at an injection point, as we do with all of our injectable objects. Okay, but what happens if we want our singleton to be instantiated at startup, to be eagerly instantiated? And what if we want it to perform some kind of startup tasks? That can be done quite easily, again, with annotations. We indicate to the container that we want our logger to be instantiated at startup by annotating it at startup. Then we have a method. This method contains code that will be executed as soon as it's instantiated. We annotate this method that contains this startup code, this startup tasks, at post-construct. So what happens here? Our logger instance is created at startup before the container satisfies any client requests, and the startup method, in this case startup task, is executed at that point. But what happens if we want to perform some kind of startup tasks within our post-construct method that is dependent on a connection to a database or web service, or some other bean needs to be created in order for that startup task to be successful? Well, we can specify this by saying that the instantiation of our logger bean is dependent upon the instantiation of another bean. So before our logger bean is instantiated by the container, it must have instantiated our our bean that is dependent on. In this case, the bean called my bean. That's the JB name of the bean. So this is what we've got. We have a bean that is created before any client requests are satisfied, that performs some startup tasks, and will only be instantiated when our my bean is created. So what does this give us? Conclusions so far. Okay, well, clearly a very different implementation. Clearly this looks nothing like what we had at the beginning. The conventional implementation is unrecognizable compared to our JEE implementation. It uses substantially less code, substantially less boilerplate code. And the code that is used are annotations. These annotations are specialized annotations that give specific characteristics to our bean and to methods within our bean. But that's not all. We can do more. Our bean's concurrency, by default, is managed by the container. However, if we want to take back control of that management, we can specify that too. Again, with an annotation on the class level specifying bean managed concurrency. We can do more. We can then control at the method level how our bean interacts, how our bean behaves, or how our methods behave. Here, we're annotating our add message method. Right, this will block on any calls up to 30 seconds as specified by the access timeout before it throws a concurrent access timeout exception. So we're now given a large number of specific annotations that allow us to control our bean. So conclusions on this. Well, substantially different manner of implementation, clearly. It's not anything like we've seen before. It's not our conventional implementation. Less code. That's always good. Less code is good code. And that's what we want to see. We want to be able to implement and have as much power over our implementations, but with less code. And that's what we have. We have these specialized annotations that control the startup behavior characteristics of our bean. It starts startup characteristics and also give us fine-grained control over the concurrency and access timeout. So we now have been given by our simplified programming model more control over our bean and more specific control. So let's have a quick look at the factory pattern. This is a creational pattern that creates a series of objects. The important thing here is that the creation is decoupled from the client. And this is what the CDI framework gives us. The CDI framework is effectively a pattern. Is effectively a factory pattern. It creates, it instantiates our POJOs, and it makes them injectable. It creates them for us. And injects them wherever it sees a qualifying injection point. Here, using the drinks machine interface to mark our injection point here with @inject. However, problem, what happens if we have 2 or more concrete implementations of our drinks machine? Which one of these drinks machines is going to inject? Not a problem. We use qualifiers. Qualifiers are custom annotations that disambiguate between different concrete implementations of the same interface. And we annotate our concrete implementations respectively. Okay, so our coffee machine annotated @coffee, and where we want to inject it, we annotate @coffee. So the container is not confused by this. We don't get an error when we deploy our applications. So again, another example of how the simplified programming model of Java EE has reduced boilerplate. In fact, there's no boilerplate code. In fact, the factory pattern doesn't really exist. Rest in peace, the factory pattern. It's no longer. The container does all the hard work for us. It instantiates our POJOs, and it injects them at relevant and qualifying injection points. And with disambiguation, we can use qualifiers to help us with that. However, that only applies to beans that are conform to JSR 299. These beans that are compliant with JS 2R99 are injectable. Okay? In short, JSR 299 says that a bean must be, POJO must be a concrete implementation and have a constructor with no arguments. There are more specifications, but basically that's it. What if we want to do something what do we want to make an object injectable that is not compliant? No problem. We have this. We have a way of creating an object, any object. In this case, we're creating a list of books. And making this list of books injectable. By annotating the getLibrary method, with @producers, we are saying to the container, I want this list of books to be injectable. I want you to create this list of books. I want you to inject it wherever you see a relevant injection point. Here, our injection points is using @library, which is a qualifier, to make it clear that this list of books generated by this getLibrary method is the one we want to inject into this point. However, this raises another question. Well, what about the freshness of the data within our list books? What about the freshness? I mean, it's not useful to start up the app, to deploy the application, to run it up. It generates a list of books, and that's there for the life of the application. You know, your list of books is going to change. In a library application, people are going to return books, are going to take books out, books are going to get thrown away because they're old, new books are going to be added. You need to maintain the freshness of that list. Well, this is done by using a scope. We can specify how often that method is called. When is that method called? And whenever that method is called, we get a new list of objects. And in this case, we can use @request scope to specify that every HTTP request, this method is going to be called. Probably worth mentioning also that if you do not specify anything, any scope, this method will inherit from the client whatever scope the client has. That's not all. We can do more. We can actually pass something quite interesting into a method of a producer method. Here we're passing in an injection point object. The injection point object contains metadata about the class that it was injected into. So in this case, we can use the injection point to get the name of the class to instantiate our logger object and return this to our class. And here we inject it, as we always do with CDI objects. So, conclusion. CDI removes the need for factory pattern. Well, OK. The factory pattern has changed, perhaps into something different. It's now a producer method. It now produces anything it wants. But this is because the container does most of the hard work for us. It's taken out the need to instantiate our objects. It does it for us. We use less code, and it makes it easier to configure our beans. They can be per class configurable, as we've seen previously. If I go back here, each class will get its own special customized implementation of the logger. This is what we want with loggers. We want it to log out the class name that it's logging from. OK. There are other patterns. That's not the only thing that is affected by the changes in Java EE. We have facade, decorator, observer, and there's many more patterns as well. I won't go through every single one. With a facade pattern, well, I suppose with a facade pattern, it's not necessarily a change, but it's been given two annotations, at stateless and at stateful, depending on whether you want it to be stateful or not. A decorator pattern, if you know this, it dynamically adds logic to an object. You already have an object in your system, and you want to add some functionality to it. This is how you would do it in Java EE. A series of annotations allow us to specify that this class is a decorator, and the @any annotation collects every instance of the product, every instance of every concrete implementation of every product interface, puts it into a product, and whenever a product, in this case, whenever a getLabel method on a product is called, it's delegated to this method. The price is reduced by 50%, as you can see here, and then the original call is sent back to the preceding object. The observer pattern. Again, this has benefited substantially, and here, very simply, if you want to observe events of type string, this is a slight trite example, but if you wanted to observe events of type string, you simply annotate your object, your method, and that's it. So, final conclusion. Efficiency savings because there's less code. Efficiency savings also because we are able to configure our object, configure our implementation, for example, of a singleton in a very specific way. We can configure its behavior in a way that we weren't able to do so before, or not so easily, or not so beautifully as we were able to do so before. And the new programming model has given us some interesting features that enhance our implementation. It allows us to do more with less, or at least the same with less. And finally, it opens the doors to new patterns, to new implementations. You can be creative. You can implement patterns in ways that perhaps you haven't done before. So you have, having given some flexibility in ways of doing that. And I would have liked to have shown you an example of that And I have a 1-hour presentation on this particular topic in which I show how you can create a collect and select pattern where the pattern collects all the objects for a particular concrete that implement a particular interface and allows you to select it based upon some kind of enum type. Whether you would want to use that in a production environment or not, but nevertheless, it shows how you can be creative in your use of patterns. And there's a book. Myself and my author, my co-author, Murat Yena, we wrote a book particularly about this topic. It's a niche topic, talking just about the way to implement design patterns in Java EE. And we talk about these topics which we've talked about today, and a lot more as well. Questions and answers. Hang on, I can't hear you, and I'm not sure if this is working. Hello? Testing? Sorry. I don't think this is working. Oh, I don't know.
Sorry. About the dependency injection and the beans are created during the construction, do you have any kind of conflict with Spring or not?
Any conflict with Spring? In what sense?
You're going to create some beans during the initiation, you're going to inject them. Is there any conflict between the annotations or
Spring does have annotations that do very similar, has very similar functionality. It has post-construct. It has, I think you can also use inject in Spring instead of auto-wired. And also you are able to start up. Also with Spring, which is quite nice, is you can specify startup order, which is quite nice. But in terms of conflicts, I don't think there are any particular conflicts. I mean, you wouldn't necessarily use these two at the same time. You'd either use Java EE or you'd use Spring. You wouldn't necessarily use them at the same time. Thank you. Any further questions? Okay, I'm going to be around all day, so if you want to have a chat later, I'm available for coffee. Thank you very much.